Hello, in this lecture you will find out the area of the green shape using two different methods. In the drawing we have three identical squares. We know that the length of one side of the square is equal to 2. Therefore all the other sides must be also equal to 2, of course. So in addition we have in the drawing this green right triangle, and our task is to find out the area of this green right triangle, that is the area of the green shape. So first of all, we get the Cartesian system in our drawing. This straight line will be the x-axis. This straight line will be the y-axis. This is the positive side of the x-axis, and this is the positive side of the y-axis, and this is the negative side of y-axis. The intersection point between y-axis and x-axis is this point. We define the intersection point as point O. Point O is defined as the origin of the Cartesian system. This is to say it is the starting point of the x-axis and y-axis, and therefore at point O the coordinates of both x-axis and y-axis is 0. So the value of point O, the coordinate x equals to 0, and the coordinate y also equals to 0. Because it is the origin, it is the beginning of both x-axes, x and y. Likewise, we define the value of this point, point V. We define this point as point V, and the value of point V will be equal to the coordinate of x-axis. Here, first of all, we know that all those three squares are identical, and therefore all the sides of the squares must be equal to 2 units in their length. And this is the negative side of the x-axis. So from point 0, we move to the left. Minus 2 plus minus 2 is minus 4, and minus 4 plus minus 2 is minus 6. So the coordinate x of point B equals to minus 6. And what is the value of coordinate y? This is the positive side of the coordinate y, and from 0 we move upward. Therefore this side is 2. So this point y equals to 2. So here, so at point B the y-axis equals to 2, because it's the same straight line. This is 2, and therefore this is 2 also. So the coordinates of point B are x is minus 6 and y is 2. Likewise, we define the vertex of the green right triangle. This point is point B. We don't know the values of point B, the value of x-axis and y-axis. So we define the value of x-axis, x coordinate of point B as x1, and we define the value of y coordinate of point B as y1. And we try to find out the value of x1 and y1 later. So in the next step we'll find out the slope of this straight line BO. The slope of a straight line is equals to the tangent of the angle that it creates between the straight line and the positive x-axis. That is to say, it is equals to this tangent of this angle. But we know that this is the diagonal of this square, and know that the diagonals of a square bisect the angles of the square. Again, the diagonals of a square bisect the angles of the square. So this diagonal bisects this angle, that is a right angle, into two halves. The first half is 45 degrees, and the second half is also 45 degrees. This angle is of course a right angle because the x-axis intersects with the y-axis in a right angle. So this angle equals to 90 degrees in its size. So in total, the size of this angle is 45 degrees plus 90 degrees. It is 135 degrees. So the slope of this straight line BO, we define the slope as m. The slope m of the straight line BO equals to tangents of the angle that the straight line creates with the positive x-axis, that is actually 45 degrees plus 90 degrees, it is 135 degrees. So the slope m of the straight line BO equals to tangents 135 degrees. Actually, the slope of functions gives us the ratio between the change in the y over change on the x. Okay, it gives us the stiffness of the straight line. So tangents 135 degrees equals to -1. So I found out that the slope of this straight line MO equals to -1. The slope, the straight line MO equals to -1. So you can see that the straight line BO goes from the left side downwards to the right side. If the value of a slope is a positive number, then the function will go from the left side up to the right side. So here we have the slope of this straight line BO equals to -1, and point O is definitely located on the straight line BO. So we define point O, that is 0, 0, the coordinate x is x1 and the coordinate y is y1, and we have the function of any straight line equals to y minus y1, and it equals to m, that is the slope of the function of the straight line, times x minus x1. So x1 equals to 0, y1 equals to 0, and m, the slope m, equals to -1. So we just have to put the data of our straight line BO inside this general formula for a straight line, and this will find out the formula of the equation of this straight line BO. We do it now, we get that y minus y1, y1 is 0, so it is y minus 0 equals to m, that is minus 1. The slope m of the straight line BO equals to minus 1 times x minus x1, that is 0. So y minus 0 is y equals to minus x, x minus 0 is x, so it is minus 1 times x. So y equals to minus 1 times x is minus x. So if we found out that the function of this straight line BO equals to y equals to minus x. That is to say, any point that is located on this straight line BO will satisfy this equation. Okay. In the next step, we'll find out the slope of this straight line BO. You know that point B, we have the value of point B, that is the x-axis equals to minus 6. We define minus 6 as x2, and the y-axis equals to 2. We'll define the y coordinate as y2. Likewise, point O is also located on the straight line BO. So we define the x coordinate of this point O as x1, and x1 equals to 0. And we define the y coordinate of this point O as y1. y1 equals also to 0. And the formula of a slope, whenever you have 2 points on the straight line, the slope m equals to y2 minus y1, that is the change on the horizontal, on the vertical axis, over x2 minus x1, that is the change on the horizontal axis, that is the x-axis. So actually the slope gives us for the change of 1 unit in the x, how many units will be changed in the y. Okay, x is the independent variable and y is the dependent variable, and the slope m gives us the ratio for a change in 1 unit of the x of the independent variable, how many units will be changed in the independent variable y. So we just put the points B and O inside this equation. We have B, point B is x2, that is equals to minus 6, and y2 equals to 2. Likewise, we have point O, x1 equals to 0, and y1 also equals to 0. Okay, so the slope m equals to y2 minus y1. y2 is 2, minus y1, that is 0, over x2, that is minus 6, minus x1, that is 0, so it is minus 6 minus 0. So we have 2 minus 0 is 2, over minus 6 over 0, that is minus 6. So 2 over minus 6 is 1/3. Is a third, minus 1/3. So the slope of the straight line BO equals to minus third. M of the straight line BO, the slope M equals to minus third. it has given us the question actually we change point B, we have 2 times point B, so we change this point as A, we define this point as A, this is point B. It is given us a question that the straight line AO is perpendicular to the straight line OB. Why? Because of the fact that those two straight lines create between them a right angle. They intersect with each other at 90 degrees. That is to say, those two straight lines AB and AO are perpendicular to each other. And whenever you have two perpendicular straight lines, you can implement rule 12. So repeat quickly on rule 12. According to rule 12, if two lines intersect with each other at 90 degrees, that is to say they are perpendicular to each other, like in our drawing, here AB, the straight line AB is perpendicular to the straight line AO because they create between them a right angle. So if two lines intersect with each other at 90 degrees, and we know that the slope of the straight line is M1, the slope of the second line is M2, then the following equation is true. M1 times M2 equals to minus 1. That is to say, the product of the slopes of two lines that are perpendicular to each other equals to minus 1. So can you implement all 12 in our drawing? Well, because of the fact that in our drawing, the straight line AB intersect with the straight line AO at 90 degrees. That is to say, they are perpendicular to each other. We already found out that the slope of this straight line AO, is M1 equals to minus 3. We don't know what is the slope of the straight line AB, so we define the slope of the straight line AB as M2. And because of the fact that those two straight lines AB and AO are perpendicular to each other, the product of their slopes must be equal to minus 1. That is to say, M1 times M2 equals to minus 1. M1 is minus third times M2 equals to minus 1. So it is now we found out that according to rule 12, the product of the slopes of two straight lines that are perpendicular to each other, that is to say M2 times M1, that is minus third, equals to minus 1. Here we multiply this equation by minus 1 and get that minus times minus is plus, so in this side of the equation we have M2 over 3 equals to minus 1 times minus 1 is 1. So totally we found out that M2 over 3 equals to 1. Here we multiply this equation by 3 and finally get that the slope M2 of this straight line MB equals to 1 times 3, that is 3. So the slope M2 equals to 3. We know that point A is definitely located on the straight line AB. So whenever you have the slope of a straight line and also the value of one point, like here, you can easily find out the function of this straight line AB. According to the formula that we already used, y minus y1 equals to m, that is the slope, times x minus x1. Here x1 equals to minus 6 and y1 equals to 2. y1 equals to 2. And the slope of this straight line AB equals to 3. M equals to 3. So just have to put the data for straight line AB inside this general formula for a straight line. In this way we find out the equation of this straight line AB, or the function of this straight line AB. We do it now, we get that y minus y1, that is 2, equals to m. M is 3, so we substitute m by 3, x minus x1. So it is x minus x1. x1 is minus 6, so it is x minus 6. So y minus 2 equals to 3 times x minus 6 is plus 6, so it is x plus 6. Here we'll open the brackets on this side of this equation. And we get that y minus 2 equals to 3 times x is 3x plus 3 times 6 is 18. So in total we found out that y minus 2 equals to 3x plus 18. Here we will add 2 to this equation. And finally get that y equals to 3x plus 20. So we found out the equation of this straight line AB. So the equation of this straight line AB is y equals to 3x plus 20. Y equals to 3x plus 20. While the equation of this straight line BO is y equals to minus x. This is point B. Again, this is point B. Point B is a common point that belongs to both straight lines. That is to say, the straight line AB definitely passes for point B, and also the straight line OB passes for point B. And if a point is located on a straight line, then it must satisfy the equation of the straight line. Repeat again. If a point is located on a straight line, it must satisfy the equation of the straight line. Point B is located on this straight line AB, therefore it must satisfy this the equation of this straight line, that is y equals to 3x plus 20. That is to say, if we substitute x by x1 and y by 1, the left side of the equation will be equal to the right side of the equation. So we do it now. We substitute x by x1 and y by 1. So y is y1, and it equals to 3x. X is x1, so x by x1, so it is y equals to 3x1 plus 20. Again, point B is located on this straight line AB, and therefore it must satisfy the equation of the straight line AB. That is to say, if you substitute x by x1 and y by 1, the left side of the equation will be equal to the right side of the equation. Therefore, we get that y1 equals to 3x1 plus 20. Likewise, point B is also located on this straight line y equals to minus x. Therefore, it must satisfy this equation. So we substitute y by y1 and x by x1. And we get that y1 equals to minus x1. So we have two equations with two missing variables, x1 and y1. So here we get the equation 3 that says that y1 according to equation 1 must be equal to y1 according to equation 2. y1 according to equation 1 equals to 3x plus 20, 3x1 plus 20. It must be equal to y1 according to equation 2. y1 according to equation 2 equals to minus x1. So to that we found out that according to equation 2, 3x1 plus 20 equals to minus x1. Here we add x1 to this equation, equation 3, and get that according to equation 3, 3x1 plus x1 is 4x1 plus 20 equals to 0. Here we subtract 20 from this equation, equation 3, get that according to equation 3, 4x1 equals to 0 minus 20 is minus 20. 4x1 equals to minus 20. Here we divide this equation, equation 3 by 4. And get that according to equation 3, 4x1 over 4 is x1 equals to minus 20 over 4 is minus 5. So x1 equals to minus 5. Here the x coordinate of point B is x1 and it equals to minus 5. And according to this equation, equation 2, y1 equals to minus x1. x1 is minus 5, so y1 equals to minus 5. Minus 5 is plus 5. So in total we found out that y1 equals to 5. So this is point B, the coordinate y equals to y1 and y1 equals to 5. So the coordinates of point B are minus 5 and 5. You see, it is located on the negative x-axis, therefore the coordinate x is a negative, and it is located on the positive y-axis. Okay. And again, it is located on the positive of y-axis, therefore y equals to 5. It is a positive number. So in the next step, we calculate the distance between points A and B. This will be the length of side AB. We calculate the length of the distance between points A and O. This will be the length of side AO, and the area of this green shape, that is the area of this green triangle ABO, must be equal to the base AB times the height AO over 2. So what is the formula for distance between 2 points? Here. What is the distance between points P and Q? This is of course a right triangle, ORP is a right triangle. This is of course a right angle. Therefore we rely on the Pythagoras theorem in order to find out the distance between those 2 points Q and P. What is the length of this straight line OP? What is the length of this straight line QR? It's actually the y2 minus y1. And what is the distance between the value of PR? PR equals to x2 minus x1. And according to the Pythagoras theorem, the square of the hypotenuse, that is to say QP square, equals to QR square plus RP square. So QP square so in the right triangle QPR by PT is a proportion for Pythagoras theorem. According to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So in this right triangle QRP, the square of the hypotenuse is QP square. And it is equal to the sum of the squares of the perpendiculars. That is to say, it is QR square plus R plus PR square. And again, in the right triangle QPR, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, QP square, that is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars. That is to say, it is QR square plus PR square. QP is the missing hypotenuse, so we have to see this, so it is QP square. And what is QP? QP is the distance between points Q and P. It is the hypotenuse, but it is also the distance between points O and P. So it is QP square equals to QR square. QR is y2 minus y1, and therefore QR square equals to y2 minus y1 square. Plus PR square. PR square equals to x2, PR equals to x2 minus x1, therefore PR square equals to x2 minus x1 square. So in total we found out that QP square, that is the square of the hypotenuse, equals to y2 minus y1 square plus x2 minus x1 square. Repeat again, QP is the length of the hypotenuse in this triangle, but QP is also the distance between points Q and P. So in this way we actually find out the distance because of the fact that QP could be any 2 points. In this way we find out the distance between any 2 points. But we found out that QP square equals to y2 minus y1 square plus x2 minus x1 square. Here we take a look out of this equation and find again that the distance between QP is also the square of the hypotenuse, or the length of the hypotenuse QP, equals to the square root of y2 minus y1 square plus x2 minus x1 square. And this is the formula that calculates the distance between 2 points. Because of the fact that points Q and P could be any points, we use this formula in order to find out the distance between those 2 points A and B, and we calculate the distance between points A and O. O is the origin of this Cartesian system. So first of all, we find out the distance between points A and B. According to the formula that says that the distance between 2 points equals to the square root of y2 minus y1 square plus x2 minus x1 square, all under the square. So the distance between points A and B will be equal to the square root of y2 minus y1 square. y2 is 2 minus y1 is 5, so 2 minus 5 is minus 3, and minus 3 squared is 9. So today we found out that y2 minus y1 squared equals to 9 plus x2 minus x1 squared. x2 is minus 6, minus x1 is minus 5, so it is minus 6 minus 5 is minus 6 plus 5, that is minus 1 squared. Minus 1 squared is 1. So today we found out that x2 minus x1 squared equals to 1. So AB equals to 9 plus 1, that is 10. So today we found out that the distance between points A and B is square root of 10 units. The distance between those 2 points A and B equals to the square root of 10 units. But AB, square root of 10 units, is also the length of side AB. Likewise, we find out the distance between points A and O. This will be actually the length of the height AO of the right triangle AOB. Again, the distance between points A and O is also the length of the height AO of this right triangle AOB. If the base is AB, then the height of the base is AO, and AO is the distance between points A and O. So this the distance between points A and O, according to the new formula, equals to the square root of y2 minus y1 square plus x2 minus x1 square. So AO, this is the distance between points A and O, is also the length of the straight line AO, that is the height of the base AB of the green triangle ABO, equals to the square root of y2 minus y1 square. y2 is 2, minus y1 is 0, so 2 minus 0 is 2, and 2 squared is 4. So today we found out that y2 minus y1 square equals to 4 plus x2 minus x1 square. x2 is minus 6, minus x1 is 0, minus 6 minus 0 is minus 6, and minus 6 squared is 36. So in total we found out that x2 minus x1 square equals to 36. So inside the root we have 4 plus 36 is 40. So today we found out that the length of the distance between points A and O, that is actually the length of the straight line AO, that is the height of the base of the green triangle AOB, the distance AO, the length of the straight line AO, of the distance of side AO equals to the square root of 40 units in its length. AO equals to the square root of 40, side AO, side AB equals to the square root of 10, the base AB of the right green triangle AOB equals to the square root of 10 units in its length. Repeat again, our task is to find out the area of this green shape. we have to find out the area of the green shape. And because of the fact that the green shape is the green right triangle AOB. So our test was to find out the area of this green right triangle AOB. And note that the area of any triangle equals to the base of the triangle times the height over 2. Repeat again, the area of any triangle equals to the base of the triangle times the height over 2. We choose the base of this green triangle AOB as AB. The base is AB. The height to the base is AO. Why the height is AO? Because it's greater than 90 degrees with the base AB. So the height is AO divided by 2. We only found out that AB equals to the square root of 10 units in its length times AO. AO equals to the square root of 40 units in its length. Divided by 2. The square root of 10 times the square root of 40 is the square root of 400 over 2. The square root of 400 is 20 and 20 over 2 is 10. So in total we should find out that the area that we are looking for in this question, that is the area of the green shape, and the green shape is actually the area of this green triangle ABO is equal to the, 10 square units in its size. Okay, so we finish with the first method. In the next step, we present you how to find out the area of this green shape according to the second method. So one side of one square equals to 2, and because of the fact that all the three squares are identical, all the sides of those three squares will be equal to 2. In the next step, we will extend those two sides and we will make a rectangle by connecting those two extended sides by a straight line. First of all, we know that this is a straight line. This is of course a right angle. This is also a right angle. Those two angles are also right angles. So in this big quadrilateral, we have 4 right angles. And therefore, this big quadrilateral is a rectangle because it has 4 right angles. And we also know that the opposite sides of a rectangle are parallel to each other. So those two sides are parallel to each other. So, and when we extend those two sides, they will be still parallel to each other, of course. Now we connect those two parallel lines by a straight line in such a way that the straight line will touch the vertex of this green right triangle. Repeat again, we connect those 2 points in such a way that the straight line that connects those two parallels will touch the vertex here. As I mentioned 1 minute ago, those two straight lines are parallel to each other. Actually, we did a construction here in such a way that we connected those two straight lines by doing perpendicular to this straight line. So this straight line is perpendicular to this straight line according to our construction. Okay, repeat again. This straight line is perpendicular to this straight line according to our construction. So in this quadrilateral we have 1, 2, 3 right angles, and therefore this fourth angle must be equal to 90 degrees inside, according to the rule that said that the sum of the angles in any quadrilateral is equal to 360 degrees. So this is the first reason that this angle must be also equal to 90 degrees inside. Another reason that this angle must be equal to 90 degrees inside is because of the fact that those two straight lines perpendicular to each other, the sum of those two one-sided interrogants must be equal to 180 degrees. According to the rule that the sum of one-sided interrogants must be equal to the sum of one-sided interrogants that are located between parallels must be equal to 180 degrees. So because of the fact that those two straight lines are parallel to each other, the sum of those two one-sided interrogants must be equal to 180 degrees. So 90 degrees plus the size of this missing angle in total must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees. So I give you two reasons why this fourth missing angle must be equal to 90 degrees in size. Again, this angle equals to 90 degrees in size according to our construction. We just built here perpendicular, and this angle equals to 90 degrees for two reasons. First of all, it is according to the rule that says that the sum of the angles in a quadrilateral is equal to 360 degrees. Here we have 1, 2, 3 angles. Therefore, this fourth angle must be equal to 90 degrees inside. And according to the second reason is that because of the fact that those two straight lines parallel to each other, those two one-sided triangles must be equal to 180 degrees. But this angle equals to 90 degrees, and therefore this missing angle must be also equal to 90 degrees in size. So inside this big quadrilateral, we have 1, 2, 3, 4 angles, 4 right angles, and therefore this is a right angle. This is, of course, a right angle because this is a square. Likewise, this is also a right angle because of the fact that this is a square. So in total, actually, by doing this construction, we created the big rectangle. This is the big rectangle. So in the next step, we define the relevant points to this question with letters. We define this point is point A, this point is point B, this point is point C, this point is point D, this point is point E, and this point is point F. define this point is point F. It is also a point that is very relevant to our question. We focus on this right triangle EDC, this right lower triangle EDC. We define this angle as angle alpha. AD, again, AD is one side of the rectangle ABCD, therefore it is absolutely a straight line. So if you focus on the right side of the straight line AD is point D, here the sum of the angles must be equal to 180 degrees according to rule 3. Rule 3 states that the sum of the angles on one side of the straight line is equal to 180 degrees. So which angles we have at the right side of the straight line AD is point D? So we're talking about the right side of the straight line AD. It's point E. Here the sum of the angles must be equal to 180 degrees according to rule 3. So which angles we have at the right side of the straight line AD at point E? We have alpha plus 90 degrees plus the missing angle, that is actually angle AEF. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. Okay, again, the right side of the straight line AD at point E, the sum of the angles must be equal to 180 degrees. That is to say, alpha plus 90 degrees plus this missing angle, that is actually angle AEF. In total, the sum of those three angles must be equal to 180 degrees according to rule 3. So we have alpha plus 90 degrees plus angle AEF equals to 180 degrees according to rule 3. Here we subtract 90 degrees from this equation and we get that alpha plus the missing angle AEF in total they must be equal to 180 degrees minus 90 degrees. It is 90 degrees. Here we subtract alpha from this equation and get that the size of the missing angle AEF is equal to 90 degrees minus alpha. This is the missing angle AEF, this is equal to 90 degrees minus alpha in its size. So it is now according to rule 3. So in this triangle, right triangle AFE, this is triangle AFE. This angle equals to 90 degrees minus alpha. This angle equals to 90 degrees, and therefore this first missing angle must be equal to alpha. Well, because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in any triangle. Likewise, we focus on this lower right triangle EDC. This lower right triangle EDC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first missing angle must be equal to 90 degrees minus alpha, according to the sum rule that says that the sum of the angles in any triangle is equal to 180 degrees. In the next step, we prove that those two right triangles are similar to each other according to angle similarity. And again, we prove that those two right triangles are similar to each other according to angle similarity rule. So we prove that the blue right triangle AFE is similar to this blue right lower triangle EDC. So write those two right triangles are similar to each other. First of all, those two angles are both equal to alpha and therefore they are equal to each other. In addition, both those two angles are both equal to 90 degrees and therefore they are equal to each other. And finally, those two angles are both equal to 90 degrees once alpha and therefore they are equal to each other. Actually found out that those two right angles are similar to each other according to angle similarity rule. So, write it down. We actually found out that this is the upper triangle AFE, and it is similar. This is the sign of similar to this right lower blue triangle EDC, according to angle similarity rule. And from the fact that those two right blue triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side ED of this blue right triangle EDC over side AF of this upper right blue triangle AFE equals to side DC of this right blue triangle EDC over side AE of this upper right blue triangle AEF. Because again, from the fact that those two right blue triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that side ED of this blue right lower triangle EDC or side AF of this upper right blue triangle AFE equals to side DC of this right lower blue triangle EDC or side AE of this upper right blue triangle AEF. It is given us the question that ED equals to 2 over AF. AF is the missing side, so we leave it as it is. And it is equals to OC and DC, DC. DC in total equals to 2 plus 2 plus 2 is 6. So it is 6 over AE. AE is the missing side, so we leave it as it is. So in total we actually found out that 2 over AF equals to 6 over AE. Here we will cross multiply this equation and we get that two times AE equals to 6 times AF. And again, if you found out that two times AE equals to 6 times AF. Here we will divide this equation by 2. We get that 2A over 2 is AE equals to 6 AF over 2 is 3 AF. So in total we found out that AE equals to 3 times AF. That is to say, if we define AF as X, then AE will be equal to 3 times AF, and AF is X, so AE will be equal to 3X. If AEF equals to X, then AE equals to 3X. And again, if AF equals to X, then AE equals to 3X. We created the big rectangle ABCD. We know that the opposite sides of a rectangle are equal to each other. So in the big rectangle ABCD, the opposite sides are equal to each other. That is to say, side AB equals to the opposite side DC. Again, in this big rectangle ABCD, side AB equals to the opposite side DC. But DC in total equals to 2 plus 2 plus 2, that is 6. So we can write here that DC equals to 6. And from this equation, AB equals to DC equals to 6. We derive that AB must be also equal to 6 units in its length. This is side AB, and it equals to 6 units in its length. AB equals to 6. AEF equals to X. So what is the length of the missing line segment FB? FB equals to AB minus AF. AB minus AF. But again, the missing line segment FB equals to AB minus AF. So the missing line segment FB equals to AB is 6. Again, AB is 6 minus AF. AF is X. So in total, we found out that the missing line segment FB equals to 6 minus X units in its length. This is the right line FBC. We know that this diagonal bisects this square. Again, the diagonal of this small square bisects the angles of the square. That is to say, this angle equals to 45 degrees inside. This angle also equals to 45 degrees inside. According to the rule that the diagonals of a square bisect the angles of the square. Again, according to the rule that the diagonals of a square bisect the angles of the square. So this square, this diagonal bisects this angle, that is the right angle, so each half must be equal to 45 degrees inside. So in this big right triangle FBC, this angle equals to 45 degrees, this angle equals to 90 degrees, and therefore this furthest angle must be equal to 45 degrees inside. Why? Because 45 degrees plus 90 degrees is 125 degrees. 125 degrees plus 45 degrees is 180 degrees. That is the sum of the angles in a triangle. So this 30 degrees must be equal to 45 degrees in its size. We have the rule that says that in front of equal angles in a triangle, they are equal size. So in this right triangle CBF, in front of those two equal angles, we have those two sides that must be also equal to each other in their size, in their lengths. But FB is x 6 minus x, and therefore side BC must be also equal to 6 minus x in its length. BC equals to 6. BC also equals to 6 minus x. 6 minus x units in its length. BC equals to 6 minus x. And now, the left of side BC is 6 minus x units from one side, but we know that again ABCD is a rectangle, and the opposite sides of rectangle are equal to each other. So in the big rectangle ABCD, side AD must be equal to the opposite side BC. But AD are equals to 3x plus 2, therefore the opposite side BC must be also equal to 3x plus 2 in its length. So BC also equals to 3x plus 2. So from one side, BC equals to 6 minus x units in its length. From the other side, BC also equals to 3x plus 2. And from this equation, 3x plus 2 equals to BC equals to 6 minus x, we will derive that 3x plus 2 equals to 6 minus x. Again, those two sides of the equation are equal to each other. That is to say 3x plus 2 equals to 6 minus x. Here we add x to this equation, and we get that 3x plus x is 4x plus 2 equals to 6. Here we subtract 2 from this equation, and finally get that 4x equals to 6 minus 2 is 4, so 4x equals to 4. Here we divide this equation by 4, and finally get that x, the missing variable x equals to 4 over 4, that is 1. X equals to 1 units in its length. AF equals to x, and x equals to 1. AE equals to 3x. X is 1, so 3x times 1 is 3. So AE equals to 3 units in its length. So in this right triangle AEF, AE equals to 3, and AE equals to 3, and AF equals to 1. Again, in this blue triangle AFE, side A equals to 3 and side AF equals to 1. So in the next step, we will implement the Pythagoras theorem on this blue right triangle FAE. And again, we will implement the Pythagoras theorem on this right blue triangle FAE. Here by PT is evaluation for Pythagoras theorem. In this blue right triangle AFE, 1 square plus 3 square equals to the square of the hypotenuse, that is EF square. And again, in the right blue triangle FAE, according to the Pythagoras theorem, in a right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is EF square, it must be equal to the sum of the square of the perpendiculars, that is to say, it must be equal to 1 square plus 3 square. 1 square is 1, plus 3 square is 9, equals to EF square. So EF equals to 1 plus 9 EF square equals to 1 plus 9, that is 10. Here we take out of the equation, and we get that the missing hypotenuse EF equals to the square root of 10 units in its length. This is the missing hypotenuse EF is equals to the square root of 10 units in its length. In the next step, we will implement the Pythagoras theorem on this right lower blue triangle EDC. In this right blue lower triangle EDC, here by PT is the relation for Pythagoras theorem. So in this blue right triangle EDC, according to the Pythagoras theorem, EC squared, that is the square of the hypotenuse, equals to 2 squared, that is 4, plus DC squared. DC is 6, so DC squared is 6 squared, that is 36. So in total, we found out that the square of the hypotenuse in this blue right triangle EDC, that is EC squared. EC squared equals to 4 plus 36, that is 40. So in total, we found out that EC squared equals to 40. Here we take out all those equations and find that the length of the hypotenuse EC with the other DC is equal to the square root of 40 units in its length. So this is the hypotenuse EC. This is equal to the square root of 40 units in its length. Our task is to find out the area of this ring shape. And again, our task is to find out the area of this ring shape. So what is the area of this ring shape? The ring shape is actually the ring triangle FEC. So we have to find out the area of this ring triangle FEC. And again, because of the fact that the ring shape is actually the ring triangle FEC, we have to find out the area of the ring triangle FEC. We know that the area of the triangle equals to the base of the triangle times the height over 2. We choose the base of this ring triangle EFC as FE, so the base is FE times the height. The height is EC because of the fact that it has 90 degrees with the base FE. So the height is EC over 2. So in total, the area of the ring shape equals to FE times EC over 2. FE, the base FE is square root of 10. Here it is square root of 10. Times the height. The height EC is square root of 40 over 2. Square root of 10 times square root of 40 is square root of 400 over 2. Square root of 400 is 20 and 20 over 2 is 10. So if you found out that they have the green shape, that is the area that we are looking for this question, in both methods is equal to 10 square units in its size. And again, in both methods, we have know that the area of this green shape is equal to 10 square units in its size. So we finish with the second method. The next step, after the lecture, we start repeat on the first method, the solution of the first method, and then repeat on the solution of this second method. So our task in this question is to find out the area of this green shape. The green shape is actually the right green triangle, so we have to find out the area of this green right triangle. So in the drawing we have three identical squares. The size of one square is 2. Therefore the size of all the squares must be also equal to 2 because they are identical. And our task is to find out the area of this green right triangle. So in the first method, first of all, we created the Cartesian system. This is the x-axis, this is the positive x-axis, and this is the negative x-axis. This is the y-axis, this is the positive y-axis, and this is the negative y-axis. The intersection point between x-axis and y-axis is defined as origin, and it is the starting point of those two axes x-axis and y-axis. Therefore, the origin that we define this point, the origin that we define as point O, has two coordinates. The coordinates of x is 0 and the coordinate of y is also 0 because of the fact that this is the starting point of those two coordinates s, x and y. So point O, the coordinates of point O is 0, 0. Then we define this point as point A. But what are the coordinates of point A? So this is the negative x-axis. So from point 0 we move to the right side to the -2, -4, -6. So the coordinate x equals to -6 and the coordinate y is a positive. Why? Because of the fact that this is the positive side of coordinate y. This side equals to 2, therefore y, the coordinate y, this point B is 2. So in total the coordinates of point B are minus 6 and 2. Likewise, we define this point as point B because of the fact that we don't know what are the coordinates of point B. We define the x coordinate as x1 and the y coordinate as y1. In the next step, we calculated the slope of the straight line BO. The slope of a straight line is the tangent of the angle that the straight line creates with the positive x-axis. So it is the tangent of the angle that the straight line creates with the positive x-axis. And here, this diagonal of this square bisects the angles of the square. So the first half is 45 degrees and the second half is also 45 degrees. So total, the angle that the straight line creates with the positive x-axis is 45 degrees plus 90 degrees, it is 135 degrees. And the slope equals to tangent 135 degrees. Again, the slope M of this straight line BO equals to tangent 135 degrees. And again, the slope M of the straight line BO is equal to tangent 135 degrees, that is minus 1. So the slope of this straight line BO is equals to minus 1. But what is the equation of this straight line BO? Because of the fact that we know that the slope of this straight line BO is minus 1, and this is point O, that is the origin of this Cartesian system, and it is definitely located on the straight line BO. And whenever you have a slope and the value of 1 point on the straight line, you can easily find out the equation of the straight line BO according to the following formula. Y minus y1 equals to m times x minus x1. That is the equation of any straight line. So we have to know what is the value of m. We know that the value of m is minus 1. x1 equals to 0 and y1 also equals to 0 because of the fact that the origin O is located on the straight line. That is to say, it satisfies the equation. Therefore, we can substitute x1 by 0 and y1 also by 0. So here, y minus y1, it is 0 equals to m. The slope of this straight line BO is minus 1 times x minus x1. x1 is also 0. This is the coordinate x of the origin O. Is also 0. So today we found out that y minus 0 is y equals to minus 1 times x minus 0 is x. So today y equals to minus x. Or y equals to minus 1 times x, and 1 minus 1 times x is minus x. So we found out that actually that the equation of this straight line BO is y equals to minus x. And this is the straight line AO. We know that the coordinates of A is minus 6 and 2, and the coordinate of O, that is the origin of this Cartesian system, is 0, 0. So we have 2 points of this straight line AO. Whenever you have 2 points of a straight line, you can easily find out the slope of this straight line AO. According to the following formula, the slope of any straight line equals to y2 minus y1 over x2 minus x1. So that is to say, if we know the values of 2 points on the straight line itself, we can find out the slope of the straight line. We have the values of point B, the coordinates of point B, that is minus 6 and 2, and the coordinates of O, that is the origin of this Cartesian system. So we find point O as x1, y1. That is to say x1 equals to 1, 0, and y1 equals to 0. Likewise, we find the coordinates of A as x2 and y2. That is to say x2 equals to minus 6 and y2 equals to 2. And the slope of this straight line AO equals to the slope M equals to y2 minus y1. y2 is 2 and y1 is 0. So it is 2 minus 0 over x2 minus x1. x2 is minus 6 minus x1, that is 0. So it is x2 minus x1 is minus 6 minus 0. That is minus 6. So today we found out that the slope of this straight line AO is equal to 2 over minus 6, that is minus 12. The slope of this straight line AO equals to minus 12. Repeat again, the slope of this straight line AO equals to minus 12. M1 equals to minus 12. AB, this is the straight line AB, that is perpendicular to this straight line AO. And whenever you have two straight lines that are perpendicular to each other, you can implement rule 12. So repeat quickly rule 12. According to rule 12, if two lines intersect with each other at 90 degrees, that is to say they are perpendicular to each other, and we know that the slope of the first line is m1 and the slope of the second line is m2, then the following equation is true. m1 times m2 equals to minus 1. You can see in the drawing the slope of this straight line is m2, the slope of this straight line is m1, and they are perpendicular to each other, and the products of their slopes must be equal to minus 1. That is to say m1 times m2 equals to minus 1. So we can definitely implement rule 12 in our drawing. In our drawing, the straight line AB is perpendicular to the straight line AO. So indicate between them the intersection point 90 degrees. We already found out that the slope of this straight line BO is m1, this is minus 3, minus 12. We don't know what is the slope of the straight line AB, so we define the slope of this straight line MB is m2. And because of the fact that those two straight lines perpendicular to each other, it means that the products of their slope must be equal to minus 1. In the end, because of the fact that those two straight lines perpendicular to each other, the products of their slopes must be equal to minus 1. That is to say, m2 times m1 must be equal to minus 1. m1 is minus 12, so minus 12 times m2 must be equal to minus 1 according to rule 12. And again, according to rule 12, m2 times minus 12, that is the products of those two straight lines must be equal to, actually that is the slopes of those two straight lines, and the product is of course m2 times minus 12 equals to minus 1. Here we multiply this equation by minus 1, so here minus times minus is plus, so in total instead of the equation we have m2 over 3 equals to minus 1 times minus 1 is 1, so m2 over 3 is 1. Here we multiply this equation by 3 and I found out that m2, that is the slope of this straight line AB, is equal to 3 units in its length. Okay. this is point B. This is a common point that belongs to both straight lines. Point B is definitely located on the straight line AB, and point B is definitely located on the straight line OB. And if a point is located on the straight line, it satisfies the equation of the straight line. Again, if a point is located on a straight line, it satisfies the equation of the straight line. That is to say, we can, the coordinates of this straight line B are x1 and y1. So we can substitute x1 by x by x1 and y by y1 in this equation of this straight line, because of the fact that this point B is located on this straight line. Likewise, we can substitute x1 by x and x by x1 and y by y1, because of the fact that point B is located also on this straight line OB. We actually did it. So here we get that y1 equals to 3x1 plus 20. Question 1 says that y1 equals to 3x1 plus 20. And here y1 equals to minus x1. y1 equals to minus x1. So here we have two equations with two variables, x1 and y1. We can easily solve those two equations. In the next step, we define that equation 3 that says that y1 according to equation 1 must be equal to y1 according to equation 2. y1 according to equation 1 equals to 3x1 plus 20. It must be equal to y1 according to equation 2. y1 according to equation 2 equals to minus x1. So total according to equation 3, we found out that 3x1 plus 20 equals to minus x1. Here we add x1 to this equation, and we found out that 3x1 plus x1 is 4x1 plus 20 equals to 0. Here we substitute 20 for this equation, and we found out that 3x1 equals to minus 20. Here we divided this equation 3 by 4, and we found out that 4x over 4 is x4. x1 minus 20 over 4 is minus 5. So in total, we found out that x1 equals to minus 5. Yeah, the coordinate x of this side line, of this point B, x1 equals to minus 5. And y1 according to equation 2, y1 equals to minus x1. But x1 is minus 5, so y1 equals to minus 5. Minus 5 is 5, so y1 in total equals to 5. The coordinate y of this side line B equals to 5. So in total, the two coordinates of point B are minus 5 and 5. So in the next step, we're going to do how to find out the distance between 2 points. What is the distance between those 2 points, P and Q? The coordinates of point Q, the x coordinate is x2 and the y coordinate is y2, while here the coordinate of point P, the x coordinate is x1 and the y coordinate is y1. So what is the distance between those 2 points, P and Q? So here, if we rely on the Pythagoras theorem, because of the fact that QPR is a right triangle, we can implement here the Pythagoras theorem. According to the Pythagoras theorem, in a right triangle, the square of the opponent equals to the sum of the squares of the perpendiculars. So in this triangle QPR, QP square, that is the square of the hypotenuse, equals to QR square plus QP square. And again, this right triangle QPR, QP square, that is the square of the hypotenuse, equals to QR square plus PR square. And what is the ref of the hypotenuse QP? Actually, first of all, we calculated the ref of QR and then the ref of PR. Of the difference of the in the y coordinate. The ref of PR is x2 minus x1. Again, the ref of this horizontal line segment PR is x2 minus x1, and the ref of this vertical line segment Q R equals to y2 minus y1. Okay. And again, Q R equals to y2 minus y1, and PR equals to x2 minus x1. And therefore, according to the Pythagoras theorem, QP squared, the square of the hypotenuse, equals to QR squared plus PR squared. This right side QPR, QP squared is the square of the hypotenuse, equals to QB squared plus PR squared. QP is the limit of the hypotenuse, so we leave it as it is, so it is QP squared equals to QR squared. QR is y2 minus y1, therefore QR squared equals to y2 minus y1 squared, y2 minus y1 squared plus PR squared. PR equals to x2 minus x1. Again, PR equals to x2 minus x1, therefore PR squared equals to x2 minus x1 squared. Repeat again, in total PR squared equals to x2 minus x1 squared. So in total, we found out that QP squared equals to y2 minus y1 squared plus x2 minus x1 squared. Here we took out of this equation, and we found out that QP, the ref of the hypotenuse QP, equals to the square root of y2 minus y1 squared plus x2 minus x1 squared. The ref of the hypotenuse QP is also the distance between points Q and P. Again, the ref of the hypotenuse QP is also the distance between points Q and P. So in total, we found out that the distance between points Q and P is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared. And because of the fact that points Q and P could be any points, we can use this formula in order to find out the distance between any 2 points. So we use the new formula in order to find out the distance between those 2 points A and B. We define the x-axis, the coordinate of x of this point B is x1 and x1 equals to minus 5. We define the coordinate y of this point B is y1 and y1 equals to 5. Likewise, we define the x coordinate of this point B, x2, and x2 equals to 106. And finally, we define the y coordinate of point B is y2 and y2 equals to 2. So we have all the data that is needed in order to find out the distance between those 2 points A and B. We just have to put the data inside this general formula for the distance between 2 points, and in this way we find out the distance between those 2 points A and B. According to the new formula, the distance between points A and B will be equal to y2 minus y1 squared. y2 is 2 minus y1 is 5, 2 minus 5 is minus 3, and minus 3 squared is 9. So we found out that y2 minus y1 squared equals to 9. We have plus x2 minus x1 squared. x2 equals to minus 6 minus x1 squared. x1 equals to minus 5, so minus 6 minus 5 is minus 6 plus 5, that is minus 1, and minus 1 squared is 1. So then we found out that x2 minus x1 squared equals to 1. So in total inside the root we have 9 plus 1, that is 2. So if you found out that the distance between points A and B is equals to the square root of 10. But it is also the length of side AB. Again, the distance between points A and B is of course the length of side AB of this green triangle ABO. In the next step, we calculated the distance between points A and O. Again, the distance between points A and O is also the length of side AO of this entire AOB. So the distance between points A and O is equal to the square root of y2 minus y1 squared. We have y2 is 2 minus y1 is 0, so it is 2 minus 0 squared, that is 2 squared is 4. So total we found out that y2 minus y1 squared is 4 plus x2 minus x1 squared. x2 is minus 6 minus x1 is 0, so minus 6 minus 0 is minus 6, and minus 6 squared is 36. So total if you found out that x2 minus x1 squared equals to 36. So in total inside the root we have 4 plus 36, that is 40. So in total if you found out that AO equals to the square root of 40. AO is the length of side AO, and is also the distance between points A and O. So side AO equals to the square root of 40 units in itself, and side AB of this green triangle ABO equals to the square root of 10 units in itself. Again, our task is to find out the area of this green shape. The green shape is the green right triangle ABO, so we have to find out the area of this green triangle ABO. Again, the green shape is the green right triangle ABO, so we have to find out the area of the green right triangle ABO. We know that the area of any triangle equals to the base of the triangle times the height to the base over 2. We choose the base as AB, and the height is AO over 2. The base is AB, the height is AO over 2. AB is square root of 10, AO is square root of 40 over 2. Square root of 10 times square root of 40 is square root of 400 over 2. Square root of 400 is 20, and 20 over 2 is 10. So in total, if you want the area of the quadrilateral for this question, that is the area of this green shape equals to 10 square units in its size. So finish with the first method. In the next step, I present to you how I put on the solution of the second method. Those three squares are identical, and therefore one side equals to 2, so on the other side must be also equal to 2, units in their lengths. And here we have DC is a straight line. Those two angles are both right angles, and those two angles are also right angles because we are talking about squares. So in this rectangle AFCD we have 4 right angles, and therefore can relate to this rectangle EFCD. Can relate to this quadrilateral EFCD is a rectangle. But we also know that the opposite sides of a rectangle are parallel to each other. So in rectangle AEFCD, side D is parallel to the opposite side CF. Those two sides are parallel to each other. And when you extend two parallel sides, then the result will be also the two parallel sides, the extended parallel sides must be also parallel to each other. So we extended DE and CF by straight line. As the result, DA must be also parallel to CB. So DA is parallel to CB, and then we did the construction, that is to say, we do perpendicular on DA at this point A, in such a way that it passes for point F of this vertex of this grid triangle EFC. So we do perpendicular on point A. So in total we have inside this quadrilateral ABCD 1, 2, 3 rectangles, and therefore this fourth rectangle must be equal to 90 degrees in size. Another reason that this fourth rectangle must be equal to 90 degrees in size, because of the fact that we have the rule that says that the sum of one-sided triangles equals to 180 degrees. So if two one-sided triangles are located between two parallels, like here, AD is parallel to BC, then the sum of the two parallel one-sided triangles must be equal to 180 degrees. But this angle equals to 90 degrees, therefore this angle must be equal to 90 degrees in size. So two reasons that this fourth angle must be equal to 90 degrees in size. So in the big quadrilateral ABCD we have four right angles, and therefore we can relate to the big quadrilateral ABCD as a rectangle. So in the next step, AD is one side of rectangle ABCD, therefore it is absolutely a straight line. So if you focus on the right side of the straight line AD at point D, here the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the right side of the straight line AD at point D? We have, actually we define this angle as alpha. This angle equals to 90 degrees according to what is given as the equation, plus this first angle, the angle AEF. In total the sum of those angles must be equal to 180 degrees according to all three. So alpha plus 90 degrees plus the missing angle AEF in total must be equal to 180 degrees according to all three. Then again, if we focus on the straight line AD at point E, at the right side of the straight line AD at point E, the sum of the angles must be equal to 180 degrees according to all three. So which angles we have at the right side of AD at point D? We have alpha plus 90 degrees plus the missing angle AEF. In total must be equal to 180 degrees according to all three. Here we subtract the 90 degrees from this equation. If we found out that alpha plus the missing angle AEF equals to 180 degrees minus 90 degrees, this is 90 degrees. Here we subtract alpha from this equation. If we found out that the missing angle AEF equals to 90 degrees minus alpha. This is the missing angle AEF is equals to 90 degrees minus alpha. Degrees in size. 90 degrees minus alpha. Degrees in size. So in this blue right line EAF, this angle equals to 90 degrees minus alpha. This angle equals to 90 degrees. Therefore, this first angle must be equal to alpha. Why? Because alpha plus 90 degrees minus alpha is 90 degrees, and 90 degrees plus 90 degrees is equal to 180 degrees. That is the sum of the angles in a triangle. Likewise, this lower blue triangle EDC, this angle equals to alpha, this angle equals to 90 degrees, and therefore this first angle must be equal to 90 degrees minus alpha according to the sum that said that the sum of the angles in a triangle is equal to 180 degrees. In the next step, we prove that those two right blue triangles are similar to each other according to angle similarity rule. So why those two white blue triangles are similar to each other? First of all, those two angles are both equal to 90 degrees and therefore they are equal to each other. In addition, those two angles are both equal to 90 degrees minus alpha and therefore they are equal to each other. And finally, those two angles are both equal to alpha and therefore they are equal to each other. So if you found out that all the three angles of this blue right triangle AEF are corresponding equal to all the figures of this blue right lower triangle EDC, and therefore those two right blue triangles similar to each other according to angle similarity rule. And again, I show that the upper blue triangle AFE is similar, this is the side of similar, to the right lower triangle EPC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side ED of this right lower blue triangle EDC over side AF of this upper right blue triangle AFE is equal to side DC of this right blue lower triangle EDC over side AE of this upper right blue triangle AFE. Okay. Again, ED or AF equals to OC over AE. ED is 2 over AF. AF is the missing side, so relative it is. And it is equals to DC. DC is total, it is 2 plus 2 plus 2 to the 6 over AE. AE is the missing side, so relative it is. So in total, if you found on that 2 over AF equals to 6 over AE. Here, of course, multiply this equation. And so if you know that 2 times AE equals to 6 times AF. Here we divide this equation by 2 and finally know that 2 times AE over 2 is AE equals to 6 times AE over 2 is 3AE. So 3AE. So AE equals to 3AF. Okay. A equals to 3AF. So if we define the length of AF as x, then according to this equation, AE will be equal to 3x. Equals to 3x. I already proved that ABCD is a rectangle, because it has 4 right angles. But we also know that the opposite sides of a rectangle are equal to each other. So in the big rectangle ABCD, side AB must be equal to the opposite side DC. Rectangle ABCD, side AB must be equal to the opposite side DC. But DC is in total is 6. And for this equation, AB equals to DC equals to 6. We know that AB must be also equal to 6 units in its length. The opposite side AB equals to 6 units in its length. Likewise, according to the symbol, in the same rectangle ABCD, side AD must be equal to the opposite side BC. But AD in total it is 3x plus 2, therefore the opposite side BC must be also equal to 3x plus 2 units in its length. BC equals to 3x plus 2 units in its length. So we know that BC equals to 6 minus x units in its length. From one side, but from the other side, we know that this is the square, and this diagonal bisects the angles, this angle. That is to say, it divides this angle into 2 halves. Each half equals to 45 degrees. So this angle equals to 45 degrees in size. This angle equals to 9 degrees, and therefore this angle must be equal to 45 degrees in size. Why? Because 45 degrees plus 45 degrees is 90 degrees, and 90 degrees plus 90 degrees it is equal to 180 degrees. That is the sum of degrees in any triangle. Therefore, this angle must be equal to 45 degrees in size. So in this big right triangle CBF, in front of equal angles, we have equal sides. So in front of those 2 equal angles, we have those 2 sides, and they must be also equal to each other in their lengths. That is to say, side AB equals to the opposite side BC. FB equals to BC. But FB equals to x minus 6 minus x, and therefore the opposite side BC must be also equal to x minus 6 minus x units in its length. So from one side, BC equals to 3x plus 2, and from the other side, BC also equals to 6 minus x. From this equation, 3x plus 2 equals to BC equals to 6 minus x. We know that 3x plus 2 equals to 6 minus x. So those two sides of the equation are equal to each other. So 3x plus 2 equals to 6 minus x. Here we added x to this equation, and we found out that 3x plus x is 4x plus 2 equals to 6. Here we substitute the 2 from this equation, and we found out that 4x equals to 6 minus 2 is 4. So 4x equals to 4. Here we divided this equation by 4, and we found out that x equals to 1. So actually, this is line 7AF, this is equals to x, and x equals to 1. Line 7AE, or side A equals to 3x. But x is 1, so 3x is 3 times 1, that is 3. A equals to 3, AF equals to 1. So in this, we implemented the Pythagoras theorem on this blue right triangle AFE. According to the Pythagoras theorem, EF squared, that is the square of the hypotenuse, equals to 1 squared, that is 1, plus 3 squared, that is 9. So in this right blue triangle AFB, according to the Pythagoras theorem, EF squared, that is the square of the hypotenuse, equals to 1 squared, that is 1, plus 3 squared, that is 9. So total EF squared equals to 1 plus 9, that is 10. EF squared equals to 10, and we to go down to this equation, and find out that the missing hypotenuse EF equals to the square root of 10 units in its length. Likewise, we implemented the Pythagoras theorem on this blue right lower triangle EDC. This blue right triangle EDC is c squared, that is the square of the hypotenuse, equals to ED squared plus DC squared. EC is the missing side, so it is EC, so it is EC squared equals to ED squared. ED is 2, therefore ED squared is 2 squared, that is 4, plus DC squared. DC is 6, therefore DC squared is 36. So total, actually found out that EC squared equals to 4 plus 36, that is 40. So EC squared equals to 40. Here we took out all those equations, and I found out that the missing hypotenuse EC of the other EDC equals to the square root of 40 units in its length. So we found out that EC equals to the square root of 40 units in its length. FE equals to the square root of 10 units in its length. Our task is to find out the area of this green shape. So what is the area of the green shape? Because of the fact that the green shape is the green triangle FEC, our task is to find out the area of the green triangle EDC. And the green shape is the area of the green triangle EFC, FEC, and therefore we have to find out the area of the green triangle FSC. The area of green triangle equals to the base of the triangle times the height to the base over 2. We choose the base as FA, the height is EC over 2. And the base is FE, the height is EC over 2. FE equals to the square root of 10, EC equals to the square root of 40 over 2. The square root of 10 times the square root of 40 is the square root of 400 over 2. The square root of 400 is 20, and 20 over 2 is 10. So in both methods, we found out that the area that we are looking for this question, that is the area of this green shape, equals to 10 square units in its size. Okay, thank you very much.